So we've done examples 1 and 2. Now we're going to jump to example 3. At this point in time, example 3 would be a great one to try on your own if you'd like to try one on your own. This is a good one to try on your own. Example 4, I'm going to talk about some special cases. But example 3, if you want to pause and try it on your own, would be a great one to try on your own. Because the graph y equals negative 2x, there's no fraction in front of x, I'm going to use the same domain points that I've been using. Remember that domain is x values, so I'm going to use negative 2, negative 1, 0, 1, and 2. That's where I always start in my table. And then this middle column is to help us show our work that we're doing negative 2 times x. In this case, that's negative 2 times negative 2, negative 2 times negative 1, negative 2 times 0, negative 2 times 1, and negative 2 times 2. And then a negative times a negative is a positive, so 2 times 2 is 4. A negative times a negative is a positive, 2 times 1 is 2. Anything times 0 is always 0, so negative 2 times 0 is 0. And then a negative times a positive is a negative, 2 times 1 is negative 2. A negative times a positive is a negative, 2 times 2 is 4, so I get negative 4. And then I'm going to write my points as ordered pairs. My x value was negative 2 and my y output, or my range, was 4. My domain x value was negative 1, my y value was 2. When x was 0, y was 0. When x was 1, y was negative 2. When x was 2, y was negative 4. So after I complete my table, then I can graph this line on my coordinate plane here. The first point that I have is negative 2, 4. So I'm going to come left 2 and up 4. Then I have negative 1, 2. So I'm going to come left 1 and up 2. 0, 0 is at my origin. There's my 0, 0. 1, negative 2 means I'm going to go right 1 and down 2. And 2, negative 4 means I'm going right 2 and down 4. And I plot my last point, or my 5th point here. Now that I have all these dots and I see that they're in a line, I know that this graph is linear. Remember that line and linear, you see the word line within linear. And now I can connect these points with a ruler or a straight edge piece of paper, something. Remember that when we do this, we want the line to go all the way through the points. We do not want to stop here and here. We want it to go all the way to the outside of the coordinate plane. And so we put arrows on our line. We can label our points. Negative 2, 4, negative 1, 2, 0, 0, 1, negative 2, and 2, negative 4. And then we can label our line with the equation y equals negative 2x. That just needs to go by one of the arrows. At this point, I'm going to double check my steps, but I think I followed them all. We made a table with values, we filled it out, we graphed our ordered pairs, we connected the points with a ruler, and we extended it past all the points. We added arrows, labeled our points, and labeled the line with its equation. We even circled that it was linear. So now, I want you to describe any patterns you notice in this table. And I want to know how is that different from example 1. So what's different about this pattern in relation to the first example, example number 1 that we did? So here's example 3. I want you to jot some things down. I'm not going to jot anything down because I actually want you to use your own brain and I want you to use your own thoughts here. And then we're going to talk about it tomorrow at your tables. What patterns do you notice and how is that different from example number 1?